Greetings. Apologies for the sound on the previous videos. This is a video about simplifying, multiplying and dividing algebraic fractions. So a little recap. If we are multiplying the two fractions, a over b times c over d, and let's do a division, a over b divided by c over d. We just multiply the numerators, a times c, the denominators bd, ac and bd. Here we write the first fraction down again. We change the operation from division to multiplication. We invert the second fraction. That means to turn upside down. AD, BC. And what's going on here is that we write in this fraction like this, which is the same as this. Which is what we have here. Okay, so these identities are really important, and you need to use them when multiplying and dividing algebraic fractions. Okay, so let's look at the concept of simplification of algebraic fractions. It's quite therapeutic doing this. It gives me pause for thought. Okay, so let's have a look at the general case. So if we have p of x, q of x, these are polynomials, we factorize p of x, we factorize q of x, so you factorize the numerator and denominator, then we look for cancellations. We look for common factors. There might not be any common factors, in which case you can't simplify the algebraic fraction. But in the questions you will get, there will often be a common factor. So let's do two of the general case. Let's do ax plus bx, and that is an x, and cx plus dx, and let's do a negative, ax minus bx, and a x minus dx. Okay, so pause the video and see if you can factorize these and cancel these algebraic fractions. Okay, so that's enough time. Hopefully you've done that now. So we factorize the numerator, p of x, factorize the denominator. X divided by x is 1, so we just left with a over b. And c plus d. Okay, so same here. Factorize the numerator. Let's leave a minus b. Factorize the denominator. That goes, that goes. We can't do anything with these, so they just left in the quotient. Okay, so let's look at some more examples. Now you can pause the video and have a go at these yourself. Okay, so let's do that then. So question 1 is negative a negative b all over negative c, negative d. Question 2 is k squared minus 1, k plus 1. Question 3, let's do question 3 up here. K squared plus 2k plus 1 over k plus 1. Let's do question 4 here. 2p squared plus 4p plus 1 all over p plus 1. And let's do 6 down here. 3x squared plus 3x plus minus 36 plus. All over x squared plus 8x plus 16. Okay, so before we do that, let's make sure our knowledge of difference of two squares and perfect squares are secure. Now, perfect square, this is a square, and by definition all sides are equal. So if this is x plus 1 distance, this is x plus 1, so is this, and so is that. So the area of that square, an expression, is going to be x plus 1, x plus 1. And if we apply the distributive property, we get x squared plus 2x plus 1. So anything in the form of ax plus b squared is a perfect square. Difference of two squares always follow this format: a squared minus b squared, or b squared minus a squared. And they factorize to give a minus b, a plus b, b minus a, and b plus a. Now sometimes there's perfect squares in disguise. So for example, 3x squared minus y squared. In fact, the 3 out. Okay, so you must know those two definitions. So pause the video and have a go doing these questions, and then we will go over the answers. Okay, so hopefully you've done that now. So for the first one, we can factorize the negative 1 out to get a plus b. Factorize negative 1 out to get c plus d. Negative 1 divided by negative 1 is 1, and that leaves us a over b and c over d. Okay, so this is a difference of two squares. They cancel, so we're left with k minus 1. So the top is a perfect square. If we divide that, we're left with k plus 1. Four. Okay, Mr. Winston's been very naughty. That should be a 2, so apologies to all those people who've been struggling with that. So we can factorize it 2 out, p squared plus 2p plus 1, all divided by p plus 1, run out of space. So that is p plus 1 squared all over p plus 1. So we're left with 2p plus 1 because the p plus 1 divide and the numerator is 1. Okay, so let's, do we have enough space to do? No, let's do this here. Okay, so I'm going to do 6 here. So we factorize the 3 out in the numerator. So just look at factors of 12, 3 and 4, select because 4 minus 3 is 1. Factors of 16, 1, 4 and 4, select because 4 plus 4 is equal to 8. Let's factorize numerator and denominator, so we get x plus 4, x minus 3, we get x plus 4, and x plus 4. So the numerator is a perfect square, cancels. So we're left with 3x minus 3 and x plus 4. Okay, so I think we are ready to try some more complicated questions. See if I can get all this in one go. Success. Okay, so not quite. So let's have a look at question 7, and you can pause the video and have a go at this yourself. Let's do 8p squared minus q squared. I'll be recognizing the perfect squares and differences of two squares. Okay, let's double check if I've done this right. 3x squared, 2x right, 4, 2, yes, p squared minus q squared, 2, yes, 2pq, yes. Okay, so pause the video and have a go at each of these questions. Okay, so hopefully you've done that now. So a very important rule when we are multiplying and dividing and adding and subtracting algebraic fractions is to always factorize before you cancel. Look for common factors of the quotient p of x and q of x and see if you can perform a simplification. So nothing cancels here. This is a difference of two squares. We can take out ax squared there to give x minus 15. So this goes, x squared goes, so we are left with 3 to x minus 1 and x negative 15. We'll just leave it like this. Okay, so let's have a go to an 8, difference of two squares. take a p out here to give 2p plus 1. We can take a p out here, give 2q. No, we can't. We take a q out. And hopefully you can see the cancellations already. Take out a p to give p minus q, and we can write that as 1 over p plus q. And let's do the cancellations then. That goes, that goes, that goes, that goes, that goes, that goes. So we're left with q over p squared. Okay, so that is everything. The key to these is practice, and we say that quite a lot. Practice makes perfect. Understanding makes perfect, and practice brings about understanding through fluency. So it's really important to use your textbooks, and I encourage you to do every single question and complete self-assessment by looking at the answers at the back of the book, marking your work, and more importantly, correcting incorrect answers.